We are going to continue our work with parabolas in standard form. And in this video, we're just going to spend time talking about how to convert from vertex form to standard form, from standard form to vertex form, and the point of each form. If we're in vertex form, we can look at that problem and know the vertex right away. If we're in standard form, we can look at that problem and know the y-intercept right away. Each form tells us some important information in a different way. We're first going to look at converting from vertex form to standard form. So down here I have two problems that are in vertex form. I want to convert them to standard form. That basically means no parentheses squared, no number out front, and all that. All we need to do is FOIL, and then just distribute the a value. To convert a parabola from vertex form to standard form, we are going to FOIL, and then distribute the a value. To convert a parabola from vertex form to standard form, all we have to do is FOIL and then distribute the a value. So in letter A, we have y equals -3 times x minus 4 squared plus 6. I'm going to rewrite this as y equals -3 times x minus 4 times x minus 4 plus 6. Okay, well, you now need to FOIL these things, and when you're done, you're going to leave that answer inside some parentheses. You're then going to distribute the -3, and then you'll just combine like terms. I think you can probably do this. See if you can go work through letter A. So, let's see. I did my FOILing, x squared minus 4x plus 16, combined like terms. I distributed my -3 and got this. Did -48 plus 6, ending with -42. That's my parabola in standard form. Now, the directions also asked us to find the vertex and find the y-intercept. I am not going to find my vertex by doing -b over 2a. I could, but there's a much easier way to do it that I'd like you to use. The whole point is, if we have a parabola in vertex form, I can look at that right away and know my vertex. This parabola was shifted right 4, up 6. That's going to be my vertex. My vertex is going to be the coordinates 4, 6. The y-intercept, I can't super easily get from my vertex form, but I can get that from my standard form. Remember, if we're in standard form, the y-intercept is just 0, the c value, the number at the end. My y-intercept is going to be 0, -42. Easiest way to get the vertex? From your vertex form equation. Easiest way to get your y-intercept? From your standard form equation. Let's take a look at letter B. Yeah, we've got a fraction. We'll be okay. We're going to get y equals 1/2 times x minus 5 times x minus 5 plus 5. Oh, you know what? Even though there's a fraction, I think you can handle this. Do your FOILing, distribute your 1/2, and leave things in terms of fractions rather than decimals. And see what you can do with letter B. Squared minus 5x minus 5x plus 25 plus another 5. Y equals 1/2 times x squared minus 10x plus 25 plus 5. Okay, y equals 1/2 x squared minus 5x plus 25 halves Plus, why don't I go right away and change my 5 over 1 into a 10 over 2, common denominator. I can combine like terms, y equals 1/2 x squared minus 5x plus 35 halves. And that is my standard form. Can you tell me the coordinates of the vertex? I'm not going to bother with negative b over 2a. I'm taking my vertex straight from vertex form. Moved right 5 up 5. My vertex is 5, comma 5. Can you tell me the coordinates, and remember I want coordinates, of the y-intercept? Well, y-intercept I'm going to take from standard form. I'm going to get 0, comma, my c value, 0, comma 35 halves. Let me see. I just lost. I don't even know what I just lost. So this is how we convert vertex form to standard form. We FOIL and distribute. Going the other direction's a little more involved. Going from standard form to vertex form means we need to do some factoring. But actually not just factoring that gives us something squared. More with that later. On the next page, we're going to start looking at 2 different methods to go from standard form to vertex form. The real way to do this involves factoring. We're going to make that method number 2, though. The first method is kind of cheating a little bit, but we're going to call this method working backwards. I want to convert this parabola, y equals x squared plus 2x plus 5, to vertex form by this working backwards method. First thing, I know what the answer is. I know that the answer has to look like y equals a times x minus h squared plus k. So I'm just going to actually state that. The answer is y equals a times x minus h squared plus k. I'm going to write that over here as well. I know when I'm done, my answer has to be in this form. I really just have to find the a, the h, the k. Well, h and k, they're just the coordinates of the vertex. So if I can figure out my vertex, I can fill those values in for h and k. Step number 2, find h and k by finding the coordinates of the vertex. Well, to get the vertex, I can just use my negative b over 2a formula, plug in to get the y coordinates. My vertex, x is going to equal negative b over 2a, which in this case looks like negative 2 over 2 times 1. Negative 2 over 2, I'm thinking negative 1 for my x coordinate. I'm going to plug in and get my y coordinate, negative 1 squared plus 2 times negative 1 plus 5. That's 1 minus 2 plus 5. Negative 1 plus 5 is 4. I'm thinking that vertex is negative 1, comma 4. I'm going to go fill that in. Y equals a times x minus negative 1 squared plus 4. Really, why don't I just go and say y equals a times x plus 1 squared plus 4. Or you can think about it as, if my vertex is negative 1, comma 4, I've got to move left 1, up 4, plus 1, plus 4. All I have left to do is find the a value. And it's actually going to be really easy. There's a reason I use the same letter for a in vertex form and standard form. The a value is the same in vertex form that it is in standard form. The a value is the same in vertex form and standard form. the a value is going to be the same in vertex form that it is in standard form. My a value in standard form, 1, there's a 1 before that x squared. So what's my a value going to be down here? Still just 1. My answer is y equals 1, no, you don't have to say that, times x plus 1 squared plus 4, or just y equals x plus 1 in parentheses squared plus 4. I'm going to pause the video so you can get caught up on any of that you need to. Let's take a look at 2 examples. We're going to convert these from standard form to vertex form, and we're going to do it by this working backwards method. By the way, there are 2 total methods we need to be able to use for these problems, and you will have to be able to use both of them. Working backwards, I know the answer. Y equals a times x minus h squared plus k. How about you take a moment, find the vertex, and you will submit that answer to Edpuzzle. Okay, my vertex, x equals negative b over 2a. That is negative 8 over 2 times negative 2. Negative 8 over negative 4, that looks like 2. My y-coordinate of the vertex is going to be negative 2 times 2 squared plus 8 times 2 plus 3. Y equals negative 8 plus 16 plus 3. I'm thinking 11, so I think that vertex should be 2 comma 11. Which means my parabola is y equals a times x minus 2 squared plus 11. Just need the a value. But that should be easy. What's my a value? A is the same that it was in standard form. In standard form, my a value was negative 2. I'm just going to fill that in. My parabola is on the screen. Oh, yeah, I am. What do you know? Y equals negative 2 times x minus 2 squared plus 11. One more. My answer is y equals a times x minus h squared plus k. Okay, can you take a moment and just find the x-coordinate of the vertex? So, vertex, x equals negative b, so 3 over 2a over 2 times 2 should be 3/4, and let's leave it as 3/4. I need to find the y-coordinate, which means I need to go plug into my formula. Y is going to equal 2 times 3/4 squared minus 3 times 3/4 minus 6. Y equals 2 times 9/16 minus 9/4 minus 6. Okay, let me see here. This is 18/16 minus 9/4 minus 6. You know what? See if you can finish this off. Get a common denominator. Subtract things. Let me know what you get for a y value as a fraction, please. Y is going to equal, let's see, 9/8. So I'm going to make 8 my common denominator. Minus 18/8 minus 48/8. Let's see, negative 9/8 minus 48/8. Negative 9 minus 48 is negative 57, I think. I hope. 3/4 comma negative 57/8. So y equals, let's see, a times x minus 3/4 squared minus 57/8. Can you tell me what the a value is going to be? A value, remember, same as what we had in standard form. That a value is going to be y equals 2 times x minus 3/4 in parentheses squared minus 57/8. So this is our first method for how we can convert parabolas from standard form to vertex form. The real method, though, involves factoring. Actually, not just factoring, but completing the square. Factoring, one reason why we did that in our last unit. Let's take a look at page 15. Second method, and again, you will need to be able to work with both of these methods. You'll have some questions on the test that say convert by working backwards. That's what we just did. You'll have some other ones that say convert by completing the square, and that's where you're going to need to use what we're about to use on this. Our work is going to look similar, but a little different from the completing the square that we did when we were solving equations. And this first example is the same example we just did on the previous page for working backwards, so we know what the answer should be. Let's make sure that we get the same answer using this new completing the square method. Step number one, and by the way, one more thing. Remember, when we're completing the square, I need to see every bit of the algebra that goes into these problems. Step number one, I need to move things around. So I get the x's on one side, and, well, before it was just the constant on the other side. Now I'm going to say the constant and the y on the other side. Let's say for step one, put the x terms on one side and the constant and y on the other. Put the x terms on one side and the constant and y on the other. Which really just means in this problem, I have to subtract 5 from both sides. Minus 5 minus 5. Y minus 5 equals x squared plus 2x. I want the x terms on one side, constant and the y on the other. Step number 2 is not going to matter in this problem, but will matter in some other problems. Remember that we can only do completing the square if there's a 1 before the x squared. And here, well, I do have a 1 before the x squared, but if we have some other number, we can't deal with that. Rather than divide everything by the a value, because that would also involve dividing the y by some number, which is just going to get messy, instead I'm going to factor out the a value on the side with the x's. Well, I'll show you plenty of examples of this, but right now it's not going to matter so much. Factor out the a value on the side with the x's. We're going to factor out the a value on the side with the x's. Again, will not matter in this problem, will matter in some other ones. I'm now finally ready to do my completing the square step. I need to go complete my right side to make it a perfect square trinomial. And I'm going to do this the same way I did before. I'm going to add half my middle number squared to the side with the x's. And then I'm going to balance it out by doing the same thing, well, at least right now, on the other side. Let me write that down, then I'll do it. I'm going to add half my middle term squared to the side with the x's. I am then going to, there's a reason I'm using this language, I'm going to balance it out on the other side. I'm going to do half that middle number squared. I'm going to add that to the right, and I'm going to balance it out on the left. So, okay, half of 2 squared. Well, half of 2 is 1. Squared gives you 1. I'm going to stick a 1 over there. And I've got to balance it out on the other side. If I add a 1 here, I'm going to add a 1 over there. Step number 4. We're going to factor. And this is our same shortcut from the last unit when we were completing the square. I need to do x and then half my middle number before squaring it, so x plus 1 in parentheses squared. If you wrote this thing out twice and FOILed, yep, you'd get your x squared plus 2x plus 1 back. On the other side, I'm just going to combine things, and I'm going to say y minus 4 equals x plus 1 squared. And what you should hopefully realize looking at this is this almost looks like a parabola in vertex form. I'm not going to go and do my plus or minus square root or any of that stuff. I just need to get the y by itself. All we have to do, I'm going to make step number 5 solve for y, but really that's just going to mean adding 4 to both sides. Solve for y. Just going to go and say plus 4, I'm going to get y equals x plus 1 in parentheses squared plus 4. That is my parabola in vertex form, which I found by completing the square. We're going to do a few together. You're going to try a few on your own, and we should be set with this stuff. First step, though, we want the x's on one side, constant with the y on the other. If there's a number out front, we'll factor it out. We'll save that for a bit from now, about 10 minutes from now. I need to add half my middle number squared to the side with the x's, and I'll balance that out on the other side. I'm going to factor into just x and half my middle number before any sort of squaring. That thing in parentheses squared. Add 4, you've got your parabola in vertex form. By the way, I could now look at this, and I could see that my vertex is going to be, let's see, this parabola was moved left 1, up 4. My vertex is negative 1, comma 4. And just for fun, if I wanted to find my y-intercept, I could get that from my original standard form problem, 0, comma 5. Let's take a look at the next page. Letter A. We're going to convert this by completing the square. I first need the x's on one side, the constant, and the y on the other side. So I'm going to subtract 19 and subtract 19. I'm going to get y minus 19 equals x squared minus 8x. I now need to add something. We need to go do half this middle number squared and add it on the right and then balance it out on the left. What number am I going to add to both sides? Well, here we go. Half of negative 8 squared, that's negative 4 squared, that's 16. I'm sticking a 16 over there and a 16 on the other side. Okay, well, negative 19 plus 16 is minus 3. So y minus 3 equals, I'm now going to factor this. I'm going to factor it into a single term squared. So I'm going to get x, and then half my middle number before I do any sort of squaring, x minus 4 in parentheses squared. I'm going to add 3 to both sides, plus 3, plus 3. We're going to get y equals x minus 4 squared plus 3. And that is my parabola in vertex form. The direction set also tell the coordinates of the vertex. I'm going to change those and also add in and the y-intercept, just because it's good for you. You know. What are the coordinates of the vertex? This parabola was moved right 4 up 3, so my vertex is 4, comma 3. Y-intercept, you're not going to look at that answer. You're going to go back to the beginning. You're going to look at your standard form. What are the coordinates of the y-intercept? I hope you're saying 0, comma 19. One more that I want to do together. Letter B. We're going to go and subtract 4 from both sides. So minus 4, y minus 4 equals x squared minus 3x. I now need to complete the square. Oh yeah, this might be a little fraction-y. That's okay. Can you tell me, as a fraction, what are we going to add to both sides? We've got to go do half that middle number squared. So negative 3 over 2 squared. That's 9/4. I'm going to add 9/4 on the right, balance it out with a 9/4 on the left. Okay, well, on the right, I need to factor. So I'm going to get x and then half my middle number before squaring. That's x minus 3/2 in parentheses squared. On the left, we need to get a common denominator so we can add those. I think my common denominator is going to be 4, so y minus 16/4 plus 9/4. I'm thinking minus 7/4. Y minus 7/4 equals x minus 3/2 in parentheses squared. Finish it off by plus 7/4 plus 7/4. And we're going to get y equals x minus 3/2 in parentheses squared plus 7/4. Tell me the vertex coordinates and tell me the y-intercept to make sure both of them are coordinates. Make sure you're using parentheses and all that good stuff. Vertex. I'm taking that from my vertex form. This parabola was moved right 3/2 up 7/4. My vertex is 3/2, 7/4. My y-intercept, I'm taking from my standard form. Y-intercept is going to be 0, 4. Before we do C and D, I want you to try 2 of these problems on your own right now. Just take out a piece of paper, blank piece of paper. And let's see, I would like you in each of these problems to convert to vertex form by completing the square. Then you're going to tell the vertex and you're going to tell me the y-intercept. I want you to do this for y equals x squared minus 14x plus 20. And I want you to do this for y equals x squared plus 5x minus 8. I'm going to make the video pause, see what you can do. Actually, how about you just do 1, and I'll do it. Then you'll do 2, then I'll do it. Try 1, and push continue when you're ready to see my work. Okay. X is on one side, y and the constant on the other. So subtract 20 from both sides. Y minus 20 equals x squared minus 14x. I now need to go do half my middle number squared and add that to both sides. So I'm going to stick stuff over there. Okay. Half of negative 14 squared. That's negative 7 squared. That's 49. I'm going to add 49 on the right, add 49 on the left, balance it out on the left. I'm going to add these things together. Negative 20 plus 49 should give us positive 29, so y plus 29. On the right, I'm going to factor into x. Half the middle term before squaring is x minus 7 squared. You write it out twice in FOIL, you get that problem back. Then I'm going to subtract 29 from both sides, minus 29 minus 29. Y equals x minus 7 squared minus 29. That's my parabola in vertex form. What is the vertex? Well, since this parabola was moved right 7 and down 29, I'm going to say 7 comma negative 29. The y-intercept, I'm taking from my standard form. Y-intercept should be 0 comma 20. Go try problem 2. Problem number 2, I'm going to add 8 to both sides. Yes, this one will be a little fractiony. I need to stick a space in there so I can add something to both sides. I'm going to do half my middle number squared. That's 25/4, so I'm going to stick a 25/4 there. and a 25/4 over there. I'm going to factor the left into x and then half the middle number before squaring, so x plus 5/2 in parentheses squared. On the left side, I need to get a common denominator. I'm thinking y plus, how about 32/4 and 25/4. This is y plus 57/4 equals x plus 5/2 in parentheses squared. Subtract 57/4 minus 57/4 minus 57/4. Y equals x plus 5/2 squared minus 57/4. Vertex. This parabola was moved left 5/2 and down 57/4, so I'm going to say negative 5/2 comma negative 57/4. And my y-intercept I'm taking from the standard form, 0 comma negative 8. The last thing that we need to do is look at how to complete the square when there's a number out front, which adds one little twist to these problems. We're going to do 2 together. You're going to try 2 on your own, and we should be all set. In letter C, I'm going to start this the same way that I always do. I'm going to, so we're back in the notes, and we're on page 16 in the notes. I'm going to subtract 99 from both sides. I want the x's on one side, the y and the constant on the other. Subtract 99, we're going to get y minus 99 equals 2x squared minus 28x. I now need to use that extra step that we haven't used so far, that says factor out the a value on this side. My a value is 2. I'm going to factor that out. I'm going to get y minus 99 equals 2 times x squared minus 14x. By the way, notice that I said factor out the a value, not the GCF. I don't want you taking out a 2x. I just want the 2 to come out front. Now I'm set to complete the square. But there's going to be an extra kind of different thing here. I need to figure out what to add over here. I need to go do my usual half the middle number squared. Half of negative 14 is negative 7. Squared gives me 49, so I'm going to stick a 49 over there. Now, I was careful in my wording on the previous page. I didn't say add that number to both sides. I said add it to the side with the x's and balance it out on the other side. Here's what I mean by that. I didn't actually change this side of the problem by 49. I actually changed this side by 2 times 49. You know what? Let me show you something. You don't need to write this down. But this right side is, if I distribute the 2, don't do this, 2x squared minus 28x plus 98. Go back to your original line. How have I changed this side? I haven't changed this side by 49. I've actually changed it by 98, which means I need to add not 49 to the other side, but I need to add 98. 2 times 49. I need to add 98 because that is 2 times 49. I think I want to add another note to this. Why are we doing this? Because on the right, you actually added 2 times 49 to that side. Because on the right, we actually added 2 times 49, not just 49. That's our extra new weird step. The rest of this is going to be like before. On the left, I'm going to get y minus 1, and on the right, I'm going to go factor that thing. Okay, half my middle number before squaring was negative 7, so I'm going to get x minus 7 in parentheses squared. Move this thing up. I'm going to go add 1 to both sides, plus 1 plus 1. Y is going to equal 2 times x minus 7 squared plus 1. That is my parabola in vertex form. I can now look at this and see that this parabola was moved right 7 up 1. So my vertex is 7 comma 1. The y-intercept is coming from the original problem. My y-intercept is going to be 0 comma 99. I want to show you one more of these, then you're going to try 2, and then we're set. Letter D. I'm going to start by getting the x's on one side, so subtract the 7 from both sides. Y minus 7 equals negative 3x squared minus 12x. I'm going to factor out the a value, the negative 3. Remember, not the GCF, just the a. So I'm going to take a negative 3 out front. I want x squared. That's going to become a plus 4x. Okay, time to actually complete the square. You're going to help me out here. What am I going to add inside the parentheses on the side with the x's? I think we need to do half that middle number squared. That's 2 squared. That's 4. Stick a 4 there. I'm not doing that to this side, though. How am I going to balance it out on the left? What am I going to add to the left? You should be doing negative 3 times 4. Don't know why I used blue on that. Should have been orange. You're actually going to change that side by negative 12. Let's finish this. Y minus 19 equals negative 3 times x plus 2 squared. Add 19. Add 19. Make sure you're showing all of this. You know if I'm talking to you right now. Y equals negative 3 times x plus 2 squared plus 19. My vertex is negative 2 comma 19. Because this parabola was moved left 2 and up 19. Y-intercept, 0 comma, my c value, 0 comma 7. I'm going to make this pause for a moment if you need to copy any of this down. And then I want you to try 2 of these. Just again on a blank piece of paper, so you can get a little bit of practice before moving into the homework. Same directions as last time. We're going to convert and then tell the vertex and the y-intercept. Try y equals 4x squared plus 24x minus 7, and y equals negative 5x squared plus 10x minus 3. See what you can do with those, and push continue when you're ready to see me work through them. Okay, in that first one, I'm going to add 7, y plus 7 equals 4x squared plus 24x. I need to factor out the a value. Let's see, y plus 7 equals 4 times x squared plus 6x. I'm going to rewrite this with some spaces. 4 times x squared plus 6x plus something. I need to do half the middle number squared. Half of 6 is 3. Squared gives you 9. I'm going to stick a 9 there. Not doing the same on the other side. 4 times 9 is 36 because I need to balance it out. I'm then going to get y plus 43 equals 4 times x plus 3 in parentheses squared minus 43 minus 43. Y equals 4 times x plus 3 in parentheses squared minus 43 should be your parabola. My vertex, the parabola was moved left 3 and down 43, so I'm going to say negative 3 comma negative 43. And the y-intercept, taken from the original, y-intercept is 0 comma negative 7. The other problem that I asked you to do, number 4, plus 3 plus 3. Y plus 3 equals negative 5x squared plus 10x. We're going to factor out a negative 5. Negative 5 times x squared minus, let's see, negative 5 times what would give me positive 10? 2, so minus 2x. Y plus 3 plus something equals negative 5 times x squared minus 2x plus something. Half that middle number, half of negative 2 squared, is negative 1 squared. That's 1. And on the other side, I'm going to balance it out with a negative 5 times 1 with a negative 5. Y minus 2 equals negative 5 times x minus 1 in parentheses squared plus 2 plus 2. Y equals, negative 5 times x minus 1 squared plus 2. Vertex is 1 comma 2. Y-intercept, 0 comma negative 3 from the original. In the homework, make sure you're reading the directions and using the method I ask you to use. If I say working backwards, I don't want any of this stuff. I want negative b over 2a, plug in, find the y-coordinate, just fill in the values. If I say completing the square, I want to see this. By the way, the reason we need both methods, the working backwards method I think in some ways is a little bit easier, but won't work later on in the year when we look at other types of shapes like ellipses, hyperbolas, circles. Completing the square is going to be the only way to convert that from one form to another. So I figure we might as well start it with something more familiar to us like parabolas before we get into the other crazy shapes later on in the year. I think that is all I have to say, and I will see you in class tomorrow online when we do our third and final method of dealing with parabolas. See you later.